or hello. Could people hear us now? Could people hear us now in the stream? Can somebody There you go, finally. All right. Take three. Take three. I'm John Limhap. I'm the community lead for the Philippine.net users group. We apologize for the technical difficulties. It's only the second time that we've tried an online event, and yeah, it is basically the first time that we're doing this from the Microsoft Philippines office, the brand new Microsoft Philippines office in One Ayala West Tower. I think it's the West Tower. And yeah, again, inviting everyone in our future events. If you have a chance to meet us face to face, please do so. We hope to see people in person again, and we'll continue to live stream our events from this venue. All right, so I'll not ask the audience to say hi again anymore. Before we begin, just going back to our sponsors, which would like to thank for making this event happen. Microsoft Philippines, very thankful to Microsoft Philippines for continuing to support us, continuing to support the Philippine.net users group through the years. PageUp, which have helped are helping me make this event possible as well. So yeah, the .NET Foundation, we'd like to thank them for letting us use their YouTube channel and their streaming, they're hosting this stream, so that we could reach a lot more people around the world. And yes, please join the .NET Virtual Users Group on meetup.com so that you could also see other .NET events and .NET related events, not just from the Philippines, but from all over the world. All right, and if you have not yet joined our social media channels, please take the time to do so. And yeah, we hope that you could join us. You could join us on social media and post these invites to your friends so that you could join us, whether it's physical or virtually. You could join us in our next events. All right, so moving on to the main topic, we have basically a double header here. We will have two MVPs who will join us. One of them is joining us from here in the Microsoft Philippines office in Makati, in Manila, and the other one is joining us from Sydney, Australia. So I will be turning you over for their talk on Azure messaging services. We will be turning it over to Brian and Michael. Yeah. I get confused with what to call him. I call him Penny.
Michael, John.
All right. So I'll turn this mic over to Brian. Let me just get Michael on the phone.
All right. Hello. I guess this is fine. All right. So hello, hearing me actually. Hello. This closer. Maybe not.
I think
you can hear me.
We muted the call. Did we mute the call?
No, it's.
All right. It's turned off.
Okay. Hello, everyone. I hope everyone is having a great time so far. You guys, you will gain
Uh, there are lots of these, but we're not really going to cover everything. We're only going to talk about the most used ones and the things that you might have used before or that you will be using in the future. So yeah, we're going to discuss why, when, and how these services will be used or you, yep.
Is audio gone again?
Really.
No. I think it should be. It should be that. Give me a moment.
Sure. Yeah, we do. It's
So for the internet connection, the event code for the internet, the Wi-Fi, just the MSFP guest is just password. It's MS event, all lowercase, without spaces. MS event 794 VN, victory N, all lowercase.
Okay. I guess we could continue, but Penny, you need to unmute your streamer.
Yes. I have to unmute my StreamYard. Yes. Yep. I've unmuted my StreamYard now.
Okay. You can proceed.
Okay. All right. Yeah. So yeah, as I was talking about, so there are lots of offerings from Azure for these messaging services, but the thing with this is that they get confusing, and most of them have overlaps, and obviously there will be, and yeah, they exist for a reason still. I mean, they did not create services that will just be the same as the others. So obviously there are reasons why they made this. So I'm gonna try to give you a bit of understanding why, not only me, but also Michael, give you an understanding why or and when and how you will use these services. So let me introduce myself first, then you can introduce yourself, Michael. I'm Brian Anthony Garcia. I'm a senior developer at SAM Consulting. We have an office here in the Philippines, but it is an Australian company, so we have employees around all around Australia, but also around the globe. So we have people working for us, or working with us in
Canada and India and South Africa and etc. And
Microsoft MVP for Azure and developer technologies. So this like the only year that I'll be a dual MVP, I think. But so far, yeah, those are things that I do. Michael.
Hi everyone. Yes, so I'm Michael, also known as MJ, Penny, Mike, depending on which timeline or multiverse we're talking about or have met. I'm also Microsoft MVP for Azure, formerly a dev tech MVP as well. I have a lot of affiliations lately, but in particular, in Philippines, I'm currently CTO of MetaDhana Technology, which is a Web3 or a blockchain company that focuses on like one of the deep techs highlighting the Filipino community. So in particular, we have Rooster Wars, which is currently in alpha release right now, and many more to come. I'm also working on other affiliations through various startups here in Australia, such as working with banks and some of more complex and things that will keep me up at night, kind of stuff. In the Azure world, and in .NET, and in the tech sphere. So all right. So a lot of things to cover today, and we'll try our best to give it a shot. Um, and basically to give you an idea on which services might be fitted on specific scenarios that you think would be best for you. All right. Let's go next slide, Brian. All right. So probably the very first question you should be asking is why you should be using messaging, right? And what is messaging in the first place, right? So yeah, go on. So if you think about it, a lot of simple, single page applications probably just need an API, a database, and a little bit of inserts on DB and things like that. That thing maybe not fitted for a messaging scenario, but it could be, right? There are a lot of reasons why you should be using messaging, and actually under the hood, even databases now have messaging, services as well embedded on it. So but to put it simply, like my general recommendation is not put messaging if you're just aiming for a small or an internal application kind of thing, because there are a lot of considerations you should consider once you venture with messaging. Next slide. Next part. So where does messaging really comes in, right? That's when, like for example, when reliability is the most important thing about your application. Like when a person or a user actually does something or tries to perform an operation, whether that's a command or a event, you expect reliability. So the classic example with messaging is that for example, you have a shopping cart application, right? And you want to check out, once you do your checkout, you submit, check out, what happens next, right? So there will be a workflow or an agent process that actually happens in the background afterwards. So obviously, what you don't want to do is that order gets inserted onto the database, and then there's another application trying to listen to that database, like periodically or something, right? So when you have that specific scenario that involves workflows, probably that's already a good sign that you should start introducing messaging. Last slide. And the last part as well is that because of the emergence of this microservices architecture, and the whole concept of event-driven architecture, and as well as the concept of CQRS, if you're into .NET, ecosystem, that's where the need or like the emergence of messaging really comes in, right? Because now you have a bunch of different services. Now, how do you make sure that service A communicates to service B and service B communicates to service C? And there are like some interdependencies, and sometimes you need service B to actually perform the operation, but sometimes you need for service C you just need to do an FYI, right? Like, hey, just want to let you know the user updated the credit card details, right? But you don't need to do anything. So so there are a lot of those scenarios now, because we're now introducing a lot of those microservices, and like messaging is the simplest and the most elegant way to make sure that all of the services communicate to each other. Because what you don't want to happen is that you're creating an API that the web application or the user is actually using, and then that same API to actually traverse across the services. So that's not really a good practice. Yeah. So that's an overview on why you should be using messaging. You're on mute, Brian.
You might. Sorry, guys. So, as I was talking about, earlier is that you guys might have heard a lot of stuff about messaging, about events, event-driven architecture, but there is still a bit of maybe confusion on what they are and what are these terms, what are these buzzwords. So obviously there are, and personally I was the same back then, and still up to now, really. So just to give you a bit of an information about the terms you hear in messaging, the first one is message. So is message. Message is a command. Message is an instruction. Message is something uh, that tells another thing to do something. So you're telling something. You're telling one service. You're a service that's telling another service to do something. So basically, if you want to place an order, you want to deliver something to someone. So yeah, most of the time it has a data within it, or um, it's a message that has a data that commands basically. And there's also event. So event is quite different. So event is also a type of message, but it is something different. So it doesn't expect the receiver to do something. So it's just broadcasting something that happens. So it doesn't require data to be passed. It's just telling the other guys that hey, something happened. So maybe an order has been placed. So that event would be order placed, order delivered. What else? Order created, something like that. So it doesn't require any data to be passed. It doesn't require anything to be done. It's just broadcasting something something has happened. So right now you might be thinking that what would be kind of like what would be your sorry, I tried to speak Tagalog. But anyway, you would be thinking or you might be asking yourself when you would use this over the other. So just always ask yourself, if the sender expects something to be processed by a receiver, then you might need messaging, or rather messages. If you don't need to process anything, if you just want to send out something, then events would be uh, would be the best way to do it. Uh, so yeah, those are the two things. Now let's talk about the three things that are basically the components within these messaging services. Yes.
So with message, if you expect something to be done, does that mean there's an acknowledgement from the other side, whereas the event doesn't have that?
Yeah, kind of. Yeah. So, and even in messages, it doesn't really expect something to kind of like to acknowledge, or the sender to acknowledge that something has happened or something has been processed. It's not really that. So it's just basically letting some other another or the receiver that something needs to be done. It's not specifically telling the sender that it's already been done. So it's not specifically that. So we're not really talking about, but that can happen on messaging.
And are both these one to many? Like a
Yeah,
message can have multiple receivers.
they can be one to many, many to many. Yeah. So yeah. So yep, or many to one. So both of them are. So yeah, let's now talk about the three main components on building this event uh, driven architecture, or at least what you would need in order for you to do this messaging thingy. Let's start off with the producer. So the producer is what generates the events or the messages. So producer is just basically the sender. So it is a service that generates the events or the messages. So it might be a web API that does something, and it also sends a message. So yeah, that is producer. Now the consumer is the one that is on the receiving end. So it receives the messages, the events. So this is where you would handle or do the processing of these messages or events. And then we have the broker. So the broker is basically what we will be mostly talking about, but you could also have set up some subscribers, topics, things like that, which we will be discussing later. But anyway, between those two, between the producer and the consumer, there would be a broker, and this broker is a certain service that will be used to handle the events and messages that we're sending and where to route them and which one is for or which message is for which receiver, things like that. So yeah, this is what we mostly provision in Azure, which are the brokers, and all these are related to what we call now as event-driven architecture. So event-driven architecture is a design approach that is centered around building distributed applications and sending data as events or messages between each of them. So yeah, that those are the terms. So hopefully that gave you an idea of what we will be talking about, because there are lots of messaging services that we'll be talking about, but we're only gonna scratch the surface. We might have another session or multiple sessions that will talk about each of these specifically and more detailed. But for now, we're just gonna give you an idea why, when, and how you will use them. Let's start off with the Azure Storage Queue, which is the most basic messaging solution in the list. And personally, I wouldn't recommend it, as obviously there are other options, or at least another option that does its job, but a lot better. So anyway, you would use this you're familiar with Azure Storage. So anyone have used Azure Storage accounts before? I would assume you guys have. Um, but definitely it would be a lot easier for you because it's just part of the Azure Storage account features. And another thing that is good with this is that it is easy to use for testing. I've encountered a lot of issues with the other messaging services before. It's really hard to debug and test. Just earlier today, um, we had to spend or basically we had to create another messaging service resource just for us to do the testing. But this guy, you can easily do the testing. You can easily set up some emulators for tests. And the queue size, it can grow up to 80 gigabytes, which is funny because the queues or the message size are only 64 kilobytes. So there's going to be like tons of messages within the queue. So little messages, but big queue as a whole. So that's kind of like what the Azure Storage Queue is, good at. If you think that if that it is good, but yeah, again, this is a queue, so data can only be consumed by a single subscriber. Um, that can also you can also set up something different, but you would rather use different services than or messaging services than use this. If it is just perfect if you're just doing queue. So one message comes in, or multiple messages from different senders comes in, but only one receiver. So that's kind of like how it works. So how to use it? You can use SDKs. They have .NET SDK, Java, Python, Node.js, and a lot more. And this is always going to be almost almost every or each and every one of these services has these SDKs that Azure is providing you. So we're probably gonna skip those parts. And for this one, it's only HTTP. So if you're looking for an AMQP protocol or AMQP, it doesn't support it. AMQP maybe later on, Michael will talk about it. But it's kind of like a better way to do messaging. It's more reliable. But anyway, just to give you a bit of understanding how it works, we have these message senders. You have web app, you have mobile app, or a service that you have, and you have a storage queue in the middle. And what you can do is you can send out messages inside the storage queue, and there's going to be a receiver. So there's only going to be a single receiver, and all of the messages that are being sent coming from any message senders will only be received by that service on the receiving end. So yeah, let's do a quick demo. Actually, this demo is just a video that I recorded. The plan was to do recording, but Michael did something else. So I'm sorry, guys, if this is going to be a bit different from what he'll demo. Just wait, go back a bit. Yep. Okay. So this is the Azure portal. So again, this is storage account. So we just need to create a storage account. So this is how you create a storage account. You just set up the subscription or pick the subscription in the resource group. You just provide a storage account name. So this is going to be for the whole storage account. And again, it has tons of features within it. And just setting up the region, the closest to where I am, and the redundancy. Probably skip that. And I'm supposed to skip this. So not sure what I was thinking, but this part actually fast forward this part because this takes a while to create. Take a minute, but this time, yeah, power off editing. But in a storage account, you can use your blob service, the file share, the queue service, and the table service. But again, we want the queue service because that is obviously what we're talking about today. So we just we can create a queue here. We can give it a name, but we're gonna skip creating it on the portal, and instead what we have here is Visual Studio. It's not, I'm not sure if you guys see it, but this is a Visual Studio. We have a sender and we have a receiver, and this is a sender. Again, I've used the SDK, the .NET SDK for this. And what I'm basically doing here is just creating a queue client to send messages. I'm just making sure that it creates the queue. If it doesn't exist, which later will happen, and if it exists, then I will generate messages. And these messages are orders. So they are order objects, and I'm just passing in an ID, address, description, create date, delivery date. But right now, it's not really that important. I just really want to show you that we can send these messages, these orders, into our queue and receive it using a receiver. So we just need to provide the connection string, and we can provide that by just going back to our Azure portal and going to the access keys. And we have here is the connection string, and we will be using this connection string for both the sender and the receiver. So right now I'm going to run this. So just a bit of console write line at the beginning. And now we're just creating the client using the connection string and the queue name. Right now, again, we don't have a queue yet, but we will be creating the queue with the help of this create if not exist. Remember, we did not create any queue in our storage account, but now if we refresh, there we go. We now have an ordered queue. And this is what we'll be using as basically the queue. And now we can add messages into the queue, which again, we can consume in our receiving end. But I'm just showing you that it is possible with the Azure portal. But what I'm going to do now instead is I'm going to create messages here in the console app. I've generated messages which are order objects, and I'm just going to send them using the queue client, meaning I'm going to send these messages, these orders into that queue client, which is the order queue. So now if I refresh this, there's one that has been created. There's going to be multiple more since it is, there are, I think, 13 messages that were generated. And as you may see, we have the message body, and that is what we are expecting. It's a JSON string that we just generated earlier. So you can dequeue the message here. You can clear the queue. Later on, I'll talk about what the queuing means. But now what we can do is, this is now the receiver. So there are a couple more things that we're doing here. We're now going to receive the message. by just creating the queue client again, or initializing the queue client with the connection string and the queue name. And now what we can do is we can peek messages. Peeking messages doesn't really read the message. It's just looking for the message for a bit. And now we can read all of the messages. So these are all 13 messages. So when you receive the message, it will be dequeued. So what does the queue means? It means that it will be removed from the queue, but it will come back in a certain like I think half a minute. It will come back. So right now it has been dequeued, and while it's dequeued, what we can do is, or while it's being read, what we can do is we can output the message, or if you have any other processing that you need to do for the orders, obviously it's not just going to be a console write line. This is the time. This is the time that you would do it to do it. And while it is dequeued, you can actually delete the messages. So right now, I've deleted all the messages, but I've also outputted them into this console app. So now there's no messages. So that is the Azure Storage Queue. Again, nothing much because this is mostly just to demo, its capability, its basic capability. So yeah, that is the storage queue. Now let's jump on to the next service. Michael?
All right. Thanks for that, Brian. So yeah, the next topic that we'll be covering is Azure Service Bus, which something who's if someone's already familiar with Azure or has been working with Azure for a while, this is probably the OG, one of the originals of this messaging platforms now. To give you an idea, for someone who's old enough to remember, back in the days, during the IIS days, we have this service called MSMQ. So that MSMQ is basically, actually one of the inspiration of an AMQP, which is the standard. Which was, it's been used by Microsoft for a very long time, especially, in the early days of .NET. Unfortunately, that, MSMQ is already deprecated, so it's not, supported anymore. And the only alternative really is to, to go cloud, and Azure Service Bus is the prime candidate for that. Um, to put it simply, Azure Service Bus is the more configurable and more robust, more scalable, and more, I would say, it's kind of like something that you have more flexibility to work on compared to the Azure Storage Queue that was demoed by Brian earlier. So Service Bus basically allows you to do more than just simple queues. It also supports topics. It also supports a lot of more complex scenarios, such as, for example, you want to do partitioning, bed lettering, or message expiration, and you can even create session based messages, meaning that like you want a specific, for example, from service A to service B, you want a specific producer and specific consumer to establish a session. You can also enforce ordering if you want to do it first in first out or last in first out. So basically, that's when you should be using Service Bus. Like if you need that more complexity or more flexibility besides the simple queuing mechanism, right? Yeah, so that's then when not to use it. Well, first off, just like what Brian mentioned earlier, testing Service Bus is actually quite challenging, um, especially doing it locally. So for a lot of these succeeding Azure messaging services, most of this requires internet connection, and unfortunately, there's no concept of like a Docker container in a Kubernetes local development cluster where you can have a service bus, and things like that. So those are, one of the really, I would say, caveats of using service bus, and most of the succeeding services as well. that we'll tackle later on. And all the price and costing, it's not like not like one message is 1 centavos, right? It's literally like we're talking about millions per month that costs cents. So that's kind of like how competitive these services are right now. But then on a grand scale of if you have millions and millions of messages happening per day or even per minute or per hour, um, service bus is something you have to really be careful of. Or and to be honest, like most of the services, right? Like because like the pricing aspect of it, it could vary a lot because you also need to consider the network costs. So a lot of these services, especially in messaging, you have to consider latency as well. So some depending on whatever is the producer or the consumer, sometimes there's some impact on the latency costs around it. All right, next slide. So how to use it? Very similar to storage queue. There's an SDK for .NET, Java, even on Go. And if you want to implement AMQP on a low-level consumption, such as, for example, you want to use AMQP on Rust or C++ or things like that, you can use Service Bus. So in the blockchain world, actually, it's a very popular Service Bus to actually try to capture a lot of transaction nodes happening in a blockchain, from Ethereum or other blockchain. So Service Bus is one of the popular ways of kind of capturing those transactions. So all the transactions happening on chain is actually something we usually capture, scan and capture and put it on a service bus to actually save to our databases. So yeah, that's like again, if you look at this diagram that Brian will be showing, it's very similar to the one that he discussed earlier. But then basically, it could be many to one, one to many, and actually there are instances where you might actually want to do a many to one or a many to not so many relationship because, for example, if there's so much traffic happening from the producer end, but you don't want to really clog up your let's say your database or your downstream services, so you can actually service bus to kind of like limit them to, hey, don't hit me with millions of transactions per second. Let's try to chew it off slowly. So yes, so service bus is also a good um, service to for those scenarios. All right. So let me do a quick demo. Let me share my screen, Brian.
Sure.
All right. And people on the audience can still see my screen, right?
Yep.
Yes, they can.
Okay, cool. All right. So luckily enough, there's this open source platform or a tool called Service Bus Explorer, which you can actually use to kind of like simulate service bus. So because the experience will be the same with what Brian showed you earlier, with having a producer and a consumer. But with the Service Bus Explorer, you actually can kind of like create or generate. Let's say you want to upload a file or send a message. Let's say this one, I want to say, hi, John, how are you? And you can have a message format, JSON, text, XML, or, send that. So basically, on the right hand is the receiver, or, I can kind of like receive the message. Then let's say I also have a capability or option to use either pick or receive and delete. So let's say I'm gonna choose receive and delete. There you go. So the one I sent earlier, the hi John, how are you? So you basically can still receive that under that same queue. Then after that like at this point in time I did receive the message, and I have the capability to either delete it or purge it. And you can even mark it as dead letter as well. So basically with service bus there are a lot of flexibility you can use for it, right? And um and to be honest, like if you're aiming for a very highly scalable type of messaging, one way or the other, service bus would be your entry point, right? You'll actually see as an emerging pattern is that, for example, for hybrid scenarios like on-prem to cloud, there will be a lot of those first point of entry service bus, then from service bus goes to the cloud, right? All right. Unmute in stream guide. All right, sorry. I'll mute again. All right, cool. So yes, so basically another scenarios where service bus is really helpful is that, for example, in a multi-region scenario, it's most likely you want to use service bus to kind of like, hey, any request coming from a specific region, you kind of like just want to distribute it on that specific region. All right, and then probably consider either service bus or other services to actually cross pollinate to other regions, right? Let's say you have a message request from let's say East Asia, and like someone from Europe actually needs to respond from that. So service bus is probably one of the good service to actually use for those scenarios. By the way, for future people who want to also use this Service Bus Explorer, it also supports event hubs, notification hubs, and relays, right? So yeah, it's really nice to have the Service Bus Explorer. Otherwise, you can always run the sample from Microsoft or from Azure portal, with their quick starts. All right, let's go back to slides, Brian. All right. So the next I'll just continue on.
Michael, there is a question.
Yes.
Can you hear me
All
okay, or you can repeat it if that's easier? Can you have a concept of a public service bus? So for example, like you receive payments via Stripe or PayPal, and they publish on service bus that the payment was received, and then you can subscribe to that and take actions on your side, or it's something like that. So like likewise, you're using Twilio to send SMSs. All you need to do is publish on their service bus, and then they do the handling of it. Is that possible? You might need to repeat it if you can hear me.
I did hear it. So the answer is yes. So it is possible. But then my recommendation there is that it works two ways, right? One, you still need to invoke those services one way or the other, whether you're consuming them and you want to do something, and that's where a service bus comes in, or you want to do something, and a receiver will have to invoke that service. For example, in Twilio, right? For example, let's say send an email, right, to this set of people, and like on the UI, you press send. Then once you hit that send, it goes through your private or in your virtual network event hub. But then under the hood, it actually talks to the Twilio API to actually send that email or SMS. So those capabilities basically those are possible, but one way or the other, you have to implement a concept of a producer or and a receiver who needs to do something, or who needs to react on something.
So generally, the providers would prefer that you use their API, which may be using Service Bus under the hood, but you don't know about that. You just say use our API, and then they figure out how to implement it.
Sorry, can you repeat that, please?
Yeah, so would a provider, like let's say Twilio or something like that, would they prefer that you just use their API? Like, because I'm sure they have a .NET API, and they might be using Service Bus anyway, but your application doesn't know that. Or would they prefer that you just put straight on the Service Bus?
Okay. All right. I think I get you. Yeah, they prefer you consume their API so that there's like a clear service boundary that hey, your service boundary is finished. Now it's their service boundary once they cross that bridge, right? Like on your end, you have to construct your message and who are the people who will be receiving it. Then once you call the API, then it's now on their service boundary. So it's now outside of your context.
Go ahead, Michael, for the next service.
All right. So yeah, go moving on to the next service. This is probably very very interesting. And something very I'm actually very fascinated and passionate about this past few months, which is the Azure Event Hub. So Azure Event Hub is it's designed for a big data scenario, right? Like when you talk about big data, it's always a question of how big, right? And what is big? And to put it simply, you want to use Event Hub if you're really talking about hundreds of thousands or millions of messages, right? And you want to kind of like consume them in a kind of like bulk way, or making sure that um, even though you have like megabytes of chunks of messages, not kilobytes, and if you have like thousands of them, pre-packaged or individual package, um, so that's where Event Hub could really be very useful. So under the hood, Azure Event Hub, specifically Azure Event Hub for Kafka, is basically a managed Kafka service. So what makes it different from Kafka is that yeah, it has a very little overhead. So that means you don't have to manage the zookeeper, the Kafka broker, and like you don't actually have to set up the orchestration layer of Kafka at all. So it's basically just a point in time, like it's just a point to point connection we're in. Hey, I got a lot of big and messages that I want you to digest quite fast, right? And the other end needs it, instantaneously, right? So you kind of like expect that it needs to happen instantaneously, like those scenarios around someone updating profiles, some, like for example in games, in blockchain, in web3. So when someone tries to buy a item, you have to make sure that by the time the person opens the game, that's already loaded in their wallet or in their inventory. So that's kind of like one of the really good use of Event Hub. And lastly is that if you want to implement something like real-time data analytics, let's say you want to count how many people are coming into the office, or how many people are like creating a heat map or a population map, that's where Event Hub also shines, right? Because it's not about the individual numbers that needs to happen. It's not like individual orders that was sent. It's about how many people, or how frequent, sorry, how fast and how many and how big are those messages that are flowing through. So that's where Event Hub really shines. um Next part. But when not to use it, by the way, just based from our kind of like exploration for the past months, Event Hub actually is quite expensive. Kafka in itself is kind of expensive, but there's a good reason for it, because of the high availability and like the real streaming and batch processing capability of it, right? Because streaming and batch processing a large chunk of data requires high CPU usage and requires a high temporal or temporary storage, which is like something like KSQL or basically utilizing a RAM capability. So that's why there's that big cost around it. And yes, it's also hard to debug and test locally. And yes, the like the really killer there would be cost considerations. Again, it's not like one message equals 1 cent. So it's really like if you're talking about millions, you have to value in like those simple transactions. Let's say if you have like 10,000 players, doing 10,000 clicks per day, and you want to put that in a dashboard, or you want to capture all of that, that's probably worth considering. How much should that be, right? It's not like you have to consider like is it worth it, right? Or do you just prefer to use service bus, so it's in a way a cheaper way, but you can't process that faster, in that kind of like instantaneous way, like batch streaming capability. All right, next part. On how to use it. Interesting enough. So what I'll be showing you here is actually not what's written in there. So, but then in terms of how to use it, you have the SDKs as usual. Um, then you also have a functions trigger, which also a very popular kind of like pattern, with Event Hub, and what Brian will be talking about with Event Grid. And probably one of the good, or probably one of the advantages of Event Hub as well, compared to just spinning up a Kafka cluster on Azure, is that you have the native integrations with the other messaging platforms or the other services of Azure, right? And that on its own is already kind of like a big deal, because that's a less, less management overhead that's gonna happen to you, right? Because at the end of the day, like you can implement Kafka on Kubernetes and like spin up a bunch of VMs, or you can use AKS, or you can use the bare bone Kubernetes. So those are options, right? But that comes with infrastructure overhead as well. But with Azure Event Hub, it's a fully managed platform. All right. So I'll be demoing. Okay. So to give you a good idea on how it works, go on, Brian, with the illustration. So let's say you have a lot of event producers, and the way it works is basically with event hubs, you have these receivers who basically kind of like receive all those events via AMQP, which is the um, then through the event hub, for a big scale application, you can actually partition it so that it's not just one kind of like bus or one broker that's doing everything. So you can actually partition it and cross partition it across different namespaces, different regions as well. And so the consumer groups can actually consume from those different partitions as well. So that means that with this kind of setup, you really can chew in a lot of data. Like I'm not sure what's the theoretical limit of this partitioning capability is, but to put it simply, if you have gigabytes of incoming data, um, it's something you can partition and manage, and kind of like um, make use of those data. Let's say, for example, if there are like millions of users of a voting application with Event Hub, you can kind of like really, even if there are so many people hammering the same service over and over, right? Like this has the capability to really chew in all those data, crunch that, and let the receivers receive all those data. Um, a lot of obviously popular services in the world, streaming services, Netflix, they use Kafka one way or the other, right? So Event Hub is what you want to use if you want to have those level of flexibility and that level of robustness in terms of messaging. All right. Okay, so let me share my screen again for the demo. So this is a bit different. And I just want to kind of like prove a point with kind of like Event Hub, right? Because at the end of the day, Event Hub again is a managed Kafka service. So what I have here is I am in Visual Studio Code, but I'm actually in my WSL, Windows Subsystem for Linux, on my Windows. So I'm running Ubuntu in my Windows, and this is my directory in my Ubuntu. And what I did is that in my bash RC, I basically declared a bunch of things here. In particular, in order to run Kafka, you need Java, OpenJDK 1.8 in particular, and you need Kafka. So I did download Kafka, and it's all in here. Right. Then what I want to do here is that basically to show that, hey, as my Kafka client, right? What I want to say is that my Kafka client is, the Event Hub. So here, this password here is the connection string of the Event Hub, right? So basically what it does is that, hey, I'm going to use this login capability or login capability as a, which uses SASL underscore SL with a plain, kind of like password connection string. By the way, you can also use OAuth if you want to. But basically, what I want to show here is that, hey, on Linux or with Windows, I can actually implement Kafka or connect to Event Hub just like how I talk to Kafka. So to do that, I just need to go to the Kafka and call the console producer. All right, and then run that. Okay. Then on the other tab, I want to run the consumer. So to do that, I just have to do the same thing, but instead of the producer, I have to use the consumer. All right. So what this does is that basically this consumer is now connected to Azure Event Hub, and this producer is connected to Event Hub as well, and using AMQP, just like how Kafka does it, right? So if I spam this message, so same message actually happens as well, like very instantaneously, like tiny microsecond gets processed and received by the consumer as well. And obviously at this point, it's just one producer, one consumer, and just single partition. But the point here is that, with Event Hub, later on, you can scale it up to a lot of partitions and a lot of regions. And you can have as many messages that you want to do, send and send. All right. And just, keep on receiving them. So yeah, so Event Hub is really a good tool or a really good platform if you have that massive data requirements, or if you actually wanna like there's an emerging pattern these days called data in motion. So like for example, like you don't have to go all the way to database and like another service have to call an API to get that data. So if you want to kind of just keep on pushing message across different services in a really fast and a really high availability and scalability way. So Event Hub is probably the best service for that. Right. So over to you again, Brian. to continue on with my second favorite messaging platform in Azure.
All right. Yeah, so that is Azure Event Hub. So just to give you an idea, by the way, we've talked about the storage queue, we've talked about the service bus, and now, or earlier, the Event Hub, and now the Event Grid. So the first two services are what we call message-based services. So those are the ones that are using the message, like the one that sends commands, instructions. Like remember if I the one that I mentioned earlier, and these two, the Event Hub and the Event Grid, are the ones that are event-based. So we just tell something, tell we're just basically telling that or saying that something happened, but it doesn't necessarily have there isn't a need to do something. We're basically just letting broadcasting uh, to everyone that something happened. So again, it depends on how you implement it anyway. So it's not really like a strict thing that needs to happen. But anyway, yeah, let's now go to event or Azure Event Grid. So Azure Event Grid is a highly scalable serverless message broker, and it allows you to integrate Azure services and any applications you have through webhooks. So, if you have your custom applications, you can set up webhooks and you basically can now send events or receive events using your custom applications. So, again, why use it? So, it has a first class integration of Azure family of services. So you'd see later on that it's very easy for an Azure or an Azure resource or any Azure service. Um, any is I think an overstatement, but lots of Azure services can easily integrate to Event Grid. Like if something happens to your Azure storage account, if a blob has been created, so something like that, easily integrate. It can easily be integrated with the help of Azure Event Grid. It is 100% managed and reliable. It is again serverless, as mentioned earlier, and it can have multiple sources or rather event yes publishers and many event subscriptions. So this is kind of like a many to many type of thing, and you can have like maybe one to one, which right now just what I'm gonna demo to you. But think of it like you can just send any of the events that are coming in from multiple services from Azure or even your custom application, and many subscribers on the other side. Uh, and it can be any Azure services as well, and also your custom applications. So that is what Azure Event Grid can give you. When not to use it, if you need streaming and batch processing, you'd obviously have to stick with Event Hub. Don't use Event Grid for that, please. And if it's hybrid or multi-cloud, it's definitely not the way to go because again, as mentioned earlier, it has a lot of integrations within Azure resources that are within the same, um, I'd say, subscription or at least within the same public Azure. It's not it, it it's not easy, or rather, as mentioned, it has a lot of friction if you try to do multi-cloud, and you wouldn't be able to use the feature the first class integration features of Event Grid. Though you can still do it with the help of webhooks, but it um, it's not something that is going to be as smooth as using Azure services to integrate. And as mentioned, with the same as previous services, it is very hard to debug and to test. So how to use it? Again, you have these SDKs, and you can use triggers like Azure Function Trigger and a lot more. There are lots of again different integrations that you can use um, with Event Grid. So how it works? You have an Event Grid in the middle. You have event publishers. It can be IoT hub. It can be storage accounts, event hubs, storage, resource groups, even resource groups, and even subscriptions actually. And you have custom topics. These can be the publishers, and you have handlers or the consumers. Can be a function, can be logic apps, can be event hubs again, even flow, Azure automation, and webhooks, which are custom. Maybe your custom application has an endpoint. You can just pass your endpoint as and it can receive the events basically. Um, so it's a push model. So basically, we're pushing the events into your webhook. So you're gonna if you're uh, subscribed to this to the event grid, you can receive events. That is, maybe you have a custom application or web application running, and it can receive those events, and you can probably do something for those events or anything. But yeah, basically that's something that you can do. And in the middle of this, or how event grid deals with this, is that you have event grid topic, and this topic can be maybe a storage or an inventory store, or maybe a storage that maybe it is. You can think of any topic that you want, maybe user login, or an ordered orders or deliveries, something like that. So many many publishers can publish, or yeah, many publishers can publish into that topic, into that specific topic, and it will go through the event grid. And for the event grid subscription, anyone that is subscribed to that topic will receive that event. So it's many to many. And again, it can have it can have a lot of topics, and it can also have a lot of subscriptions. So it's not just a single topic, it's not just single subscriptions. You can set up tons of topics if you need to, and you can set up tons of subscriptions as well. So yeah, that is Azure Event Grid. So let me show you a quick demo. Unfortunately, again, it's just a video. And I'm not sure if you're seeing it, but yeah, this is basically just how you can create an event grid. You start off with an event grid topic. So what you can do is you can create a topic. You can pick a resource group, provide a name for the topic. Right now, I'm just gonna call it event grid demo. Just select a region and just create it. So what we're basically creating now is the topic where we will be sending our messages, where we will be publishing our, or rather, events. And what we can do now is we can create an event subscription. And this time, what we want to do is to have a subscriber that is going to be an Azure function. So a bit different than the previous demo, because this one you can set up the Azure function as your receiver or consumer. You can set up event types, or basically what event you're using, or yeah, what kind of event you're sending. Right now, I have an Azure function app already created. So what I can do is actually select a trigger. So there are lots of triggers. As mentioned by Michael earlier, you can set up service bus, event hub triggers with Azure functions. So you can basically set up Azure function as your receiver. But with this one, it's going to be for the event grid. And setting up an event grid uh, Azure function subscriber is as easy as this. It's just, just need to fill it up. Just need to pick the subscription, the resource group, and then the function app itself, and just press create, and that's it. That's just, creating the subscription, all in the portal. So now you have a topic. Now what we can do is we can send out, or we can send events into that topic. And what we need is just the topic endpoint and the access key. And we just create a client for that. So just need to retrieve the access key. And the endpoint will be on the overview of the resource. And now what we can do is now we can generate an event which we will be sending into our event grid. And what happens here is that once it's sent, right here is the data. You see, it's just showing that this is an event data. Now this is my Azure function. What will happen is just, it seems very simple, but if you think about it, you can do a lot of things with this one. You can send lots of messages into a single topic or multiple topics, and you can have multiple Azure functions triggered with that. And you think about it. For me, I've used it in setting up microservices. It's very helpful for microservices as uh, since our project needs a lot of event sourcing and updates or at least notifications when it comes to updating a view or a materialized view from our Cosmos DB. So uh, whenever we update something or we do something in our let's say list of data or records, or update any create a new data or a new record from our database into our database, what we can do is you can just send an event, and that event can be anything, and it can be received by our subscribers. And for us, it's Azure functions that what we it's just almost the same as what we've done here. So that is for the event grid. Now let's now jump into the next one. Now this is quite different from the from the previous ones that we've been talking about. This is not message sending. Well, technically it still is, but it's quite different because this is mainly focused on sending push notifications to mobile applications or for your mobile applications or even web actually. So Azure Notification Hub, I'm not really assuming you guys know this, but if you're a mobile developer, you have probably heard of it. And if you're a mobile developer, you probably heard of push notifications. And if you have a mobile phone, you probably received push notifications before, obviously. So notifications is what you get when someone wants to notify you on your phone. And the thing is that it is complicated to set up notifications with um, with mobile applications, and it's added. There's added difficulty to set it up on multiple platforms. So it's not just maybe you're setting it up on Android, but you also need to support iOS. Also need to support Windows in this case. Let's just say Windows as well. So that it is there's an added difficulty with setting up this kind of push notifications setup. So with the help of Azure Notification Hub, it makes things a lot easier to do push or to use a push or yeah to do push notifications using their push engine to send notifications, but not only to send notifications to multiple platforms, but also to register these devices for notification. So that's also an added feature. Well, not an added feature. That is one of the biggest features of Notification Hub, and that is also one of the hardest things, or rather difficulties that you would experience as a mobile developer. It is not easy to register mobile devices for notifications for like Apple for or iOS and Android. I specifically had issues with Android, as there is a different have been different ways to do device registrations or yeah, device registrations for notifications with Android, because they've kind of like had different versions of how you do it on their previous versions, on previous Android versions, and on current versions. So there probably would be a lot more changes in the coming, probably in the coming next coming versions. But it is there is an added difficulty when it comes to setting that up. But with Azure Notification Hub, it is managed, so it gives you a lot of you know it alleviates a lot of pain when it comes to setting up these push notification engine. Um, but again, when do you not use it? Because in Android, I would say there's a lot of help coming from the Firebase, anyways. But nowadays, when you set up push notifications, you would set it up for two platforms. So it's going to be iOS and Android. So if you just need it for an Android, you just probably stick with Firebase. It probably would do everything that or give you everything that you need. But let's say if you're using Xamarin, so I'm not sure if you guys have heard of Xamarin before. Xamarin is what you use for to develop mobile application, cross-platform mobile applications. So you can it can be it can build Android, iOS, Windows applications in a single code base. So Azure Notification Hub is kind of like the best way to send or to set the push notifications up with Xamarin. It's not designed for real-time messaging. The next one is, which is the SignalR service, which Michael will talk about, and it's not designed to communicate back. It's just sending notifications. It's not expecting anything back basically. So yeah, how to use it? There's again SDKs for the server side and also for the client side. So Xamarin, we have it. React Native, native iOS and Android, but yeah, it's mainly a good thing for any mobile platforms. So how it works, you have, let's say you have a web API or a web app that sends out that needs or you trigger, and what it does is sends out notification. And if it does that, then if you have a notification hub, you can just send that notification into the notification hub, and you can set up these APNS, the WNS, and the FCM or the Firebase Cloud Messaging, and send that notification into these push notification services. And that is basically how notification works. So it's just sending the notification into the right devices, into the that has the application. So of course, yep.
So do you give Azure Notification Hub your Apple and Google developer IDs?
And
So it's-
not really those specifically, but yeah, you have to provide something. As for Firebase Cloud and Apple push notification, well, let's go with the Firebase first. You just need to provide a key coming from Firebase, which I'll show it in the demo later. But for the Apple, it's also the same thing. I think you're gonna need to provide a certificate. Yes, I think it's a certificate that is gonna come from your Apple developer account. So
and then does Azure's charging like what per message?
not per message, but well, if it it depends. It depends because obviously not per message, but when you get to a certain point, like maybe a million message, then that's the time when you'll be charged. Also, there's only a limitation on the number of registrations, so it depends on the pricing tier. So later on, I'll show it to you as well.
And Apple and Google are cool with this, like because it kind of seems like Azure's put a front end onto using their own notification services.
Well, I mean, it's for Apple and Firebase, or rather for Google. It's not really. They don't really. You don't really need to pay for it for you to send notifications. What Notification Hub does is it makes things a lot easier for you. It handles the things that you would need to handle on your back end, but this time it's just being handled by Notification Hub. So there's nothing really that is takes cost a lot lower. It's not that you can actually do this without paying, but since you want to make things a lot easier, Notification Hub is there for you, and you have to pay for it. It's not really that expensive. It's probably for us that has maybe thousand of device registrations, and maybe that we send messages like maybe
$1 per million.
yeah, so yeah, $1 per million. But if we send notifications like 10,000 or hundreds of thousands of notifications per month, we barely get charged. It's less than $1 actually.
But
So
like Apple's totally fine with you're giving your signed certificate to Azure,
yeah.
saying send on my behalf, and Apple said no problem that you're using a third party to hook into our network for messaging. It's not going straight in. That's all fine. They're not going to shut this down someday.
I don't think so. We've been using this since 2015, and yeah, nothing's really changed. So, it's not that nothing's really changed. It's something has changed on Firebase that they have yet to fix in Notification Hub. Actually, what we're using in Firebase, which I will show later, we're using a legacy key now because they have yet to update how we use keys because Firebase provides a new way or a different key now. And what we need is to just enable a legacy key in order for us to connect Firebase into the notification hub, which is a bit weird, but I guess they'll be updating it very soon on the notification hub side of things. But for Apple, it works. Actually, they've just updated it that you don't need to upload your certificate once a year or annually. Instead, it's always going to be there once you upload it. You don't need to think about any of it. So you don't really have to any problems with setting up notification hub that you have to remember annually or in specific period. So yeah, that is notification hub. So a bit of a demo. It's not really a whole demo because building this whole mobile app and the web API would take definitely a long time, maybe 15 minutes at least. So we're gonna be just jumping into the notification hub, and I already have a mobile app set up and also a web API set up. But anyway, so this is how you create a notification hub. You start off with creating a namespace. So a namespace is where your notification hub lives. So there is a namespace that is basically a container of a notification hub. So that is the pricing. Sorry, I skipped that part. But um, check that again. Probably let's just get back to that later. But anyway, this is basically Firebase. So what I need to do is just go to the project settings and retrieve this server key. And as you may see, it's already a legacy one. You should be using this one, but you just need to provide the key by picking the Google one. So you can set up these. So this part right here is the web API. Now, the web API is the one responsible for doing the registrations. So if you want to register an a device into your notification hub in order for it to receive notifications, so you would have to set up a web API for that, or maybe just set it up on your mobile application as well if you want to. But if you want to have or to make it loosely coupled, you may want to set up a web API mainly to do registrations. So the installations is also what they call registration. So it's registration or installation. Depends on what you want to call it. But basically what's happening here is just it's creating a notification hub client coming from the connection string that was from the connection or from the notification hub. And yeah, those are the details that came from the notification hub. And on this part right here, yep. Sorry, this is on the mobile app already. This is the device registration. So we're just calling that API. Is the sending of the API or of the HTTP client, and we're just passing in the device ID into the web API, and we're registering that device ID into the notification hub. So that is basically what how we tell Notification Hub that okay, this is the device ID, and this is for FCM or fire-based messaging or cloud messaging. And you can pass in if it's an iOS, this is a device ID, but for the APNS or Apple Push Notification Service. So it knows where it should be. Like if it's an iOS, if it's an Android application or an Android device. So yeah, that is how you create the register. You do the registration. Yep. So now what we have here is that when we click the register button, we will be executing that register device async, which again passes the device ID. And once it's registered, so again, this button click is not necessary. It can happen maybe when you open the application, when you log in. So it depends on when you want to set up the registration. Or yeah. And now what we can do is there's actually a way for you to send notifications through the portal, but also you can send notifications through maybe a web API or maybe a trigger that happens on your mobile app. Like when you click send, then we can trigger a notification. But this time we can send notification through the notification hub on the Azure portal. And we can pass in a payload right here. So this is just a sample payload. And we can send it to any specific or to a specific tag, like maybe the tag would be the user ID. So only that user on any device that he has will he receive that message or notification. So yep, once you click the send, now this part of the code is the Android's way of handling notifications that are coming in. So it's now just reading the message. So this is the message that we just sent. And you know what? The funny thing here is that I didn't show the actual push notification showing on the Android application. The reason behind that is I wasn't able to make it work. It's not that it didn't work. It's just that I was on Do Not Disturb and I didn't notice until I finished the demo. But anyway, what happens here is just, it shows the notification and that's it. So, yep, that is the notification hub. I think we are on to our final.
Quick question.
Oh, sure.
So when the user deletes the app, does the app the uninstall process tells Azure like unsubscribe from the?
So along with the device ID, it also includes the application ID. It does understand that if the app is not it's not in the mobile phone anymore, it will not send the notification. Now, if you are logged in in the application and you still have the application running or in the background or closed, it will still receive the notification as long as you handle it properly on your mobile app. It can still be received. So, yeah, whatever that you get on on your mobile phone, like when let's say an e-commerce application is sending you notifications, that is exactly what you can do with Notification Hub. And you can specify if it's only for this specific user, only for this group of people or group of user, or maybe for a specific or for everyone. So yeah, that is what you can do with it.
Well, so like you showed code where it's registering the device to receive the notifications.
Yeah.
So when they uninstall the app, is it sending passing some kind of message to say, now let's do a deregister? Because otherwise Azure Notification Hub has this list of all these devices that should receive notifications, but they just uninstalled the app.
Yeah, so the funny thing about this is that when you have these devices or you have these device registrations, even though they deleted the app already, there will still be registered there. Yeah. There is also deregistration. Yes, there is.
Yeah.
But people who has deleted the app or have deleted the app without logging out, which would trigger the deregistration if you want to. If they deleted the app without logging out, it's just gonna be there, but it will not receive the notification anymore because the notification hub will understand that this guy doesn't have, or this mobile phone doesn't have the application anymore. Yep. So when you try sending it to a specific user, even though he's still registered, but the app doesn't have the application anymore, you will see that there's 0 recipients of that notification.
Yeah, it's interesting. You think when you do an uninstall, you could put a hook into your app, like maybe all of the uninstall processes call this function if it exists in the app, and the app could do things to clean up. But I don't know if that has it. I don't remember. But
You probably can do that. I think it is possible, yeah. But some developers are lazy to do
yeah,
that
they gotta be doing
because
it.
it won't send any notifications.
Yeah, who cares about
anyway.
the cost? Yeah.
Yeah, but it is possible. You're right. Yep. So that is for the Azure Notification Hub. Now we are going to our last service, which is the Azure SignalR service. So Michael.
Yes, hi. Also just to add up onto that one, right? So actually about those uninstalls with the notification hub, actually because you can manage things on the back end, you actually have more capability or control on the behavior of this, right? Because you can also deregister uh, devices from the back end directly using notification hub. So let's say you want to create a query, okay, devices that we tried to push message 10 times and keeps on failing, let's just deregister them, right? So those kind of capability is something you can also do on the back end. And that's one of the power of Notification Hub. Moving on. Yep, go on.
Yep. Just to add up on that, just one last thing, and you have SDKs for that, and it is very helpful. Yep. Go ahead, Michael.
All right, moving on. SignalR. Okay, so SignalR, 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 depending on how you pronounce it, is, like to put it simply, in the, again, probably 10 years, 12 years ago, SignalR has been kind of like the .NET way of WebSockets, right? Like the de facto way of doing WebSockets on .NET. And up until now, you probably still want to use SignalR, especially if you're in that ASP.NET ecosystem. And but throughout the years, a lot has changed already. So back then, you need to use SignalR. You actually have to create the SignalR server inside your ASP.NET backend application, right? To actually spin up the service. But now what happened is that let's say the messaging components of SignalR, what if you just want to use Azure, instead of actually building it and putting it inside ASP.NET. So that's where Azure SignalR service comes in. So, and not just the WebSocket aspect, a lot has changed already in terms of other supports with SignalR. In particular, there's now support for AMQP yet again for SignalR. So if you also want to use AMQP, and the other thing is that other than WebSockets, SignalR now supports RPC, which is remote procedure calling. So to put it simply, where you want to use something like SignalR or this type of service is more on the polling capability, or like an always on, always connected scenario, right? So compared to Notification Hub, wherein it's like a fire and forget, SignalR is designed more around, hey, let's try to communicate in real time. Let's not lose our connection, the two of us. Instead of sending an API, like two web applications trying to send API and like to monitor database change and things like that. Why not, the two of you just chat, right? Like, why not the two of you just communicate on the same broadcast channel? So that's where, a concept of a pub sub or a publisher to subscriber comes in. And where SignalR comes in is that it's designed for like an always on, like, hey, let's establish a connection on a specific hub or a specific, channel. And let's not, whatever is being sent on that channel, it's going to be broadcasted to all the subscribers. By the way, in just a quick disclaimer, I actually just learned about this 2 weeks ago. There's now a new service as well, which is called Azure Web PubSub, which is kind of like a more vanilla flavor of SignalR. So Azure Web PubSub is basically like a managed WebSocket. So if you want to just use WebSockets in the future, like without the SignalR way of implementation, like for example, if I recall, there's like a Y socket or that you can use on Node.js or in Python. So there's now a service called Azure Web PubSub, because right now, if in order to use SignalR or WebSockets using Azure SignalR on Python and Node, you have to use the SignalR client libraries. All right. So going on, Brian. So when not to use it, real-time messaging is not a requirement, because again, there's a cost associated with it. And the other, like real-world experience I had, that becomes a challenge with SignalR is the concept of a multi-region, right? Like, how are you going to establish a connection between someone who's in the US and let's say someone in Asia, right? Like, because at the end of the day, if you want to create a pub sub mechanism, one way or the other, they need to connect to the same location. Whether the publisher is in US, then one way or the other, they need to connect on the same resource. So that's one of like a big pain point in there. And also cost consideration. So that's where hosting your SignalR um, capability would be handy. So let's say if you have a really experienced and reliable SREs or infrastructure people, one thing you can consider is that instead of using SignalR service, maybe you can just bake in SignalR onto your ASP.NET application that's kind of like distributed across the world, and let them kind of like do the smarts around which how are they going to connect on a specific, let's say, container instance, rather than on a specific SignalR service region. So next part, how to use it. .NET SDKs in Unity, Xamarin, Java, JavaScript, TypeScript. By the way, I did mention their Unity because SignalR is actually very popular with games. So especially those who are built in Unity, because there's like a really rich library in .NET and C# for SignalR. And you can use WebSockets. You can use Message Pack. You can use RPC. You can use AMQP as well. A lot has, like there are a lot of ways of using SignalR. Right. But let me okay, in terms of the diagram, so you have an upstream. So let's say your upstream is a web application, or that just kind of like, hey, I have an announcement to make, or let's say like you have a bot, like the bot is a hosted service that is your upstream that just wants to push messages to downstream services. And by the way, with that line that you see there, it requires that all of them needs to be connected to that same hub at the same time. So compared to notification hub, wherein like it's a fire and forget, this one is like, hey, all of you needs to be connected. Otherwise, if you're not connected, you're not going to receive it. So that's kind of like how you establish that connection. So through WebSockets or RPC. All right, so over to demo. So for my demo, basically, if you are already in the ASP.NET family or in the .NET family, there is now a injecting the SignalR service is just a one-liner now, which is just on your services. You can just inject SignalR and you add your SignalR and pass in your connection string. So that's it. Like that's just how to kind of like build in SignalR now in your application. Then in terms of the actual implementation, same as before, like back in the days with SignalR, you just need to implement the hub class. And that hub class, basically you need to have the specific public methods, which is the simple ones or the default ones, or add to group, remove to group, on disconnected, send ready to group. No, not that one. So add to group and send message to group. Those are the two required ones. And basically, like when you add to group, what do you want to do, right? And when you try to send message to group, what do you kind of like want to say to the group, right? Like all of those connected in there. So to give you a on how we actually simulate Rooster Wars or other games. So I have it's a simulation of, let's say, two roosters fighting each other. So like there's the ID. So the idea there is that for these two clients to actually connect to the same hub or same SignalR hub. So you try to find a match, and that at that point in time, this is already connected to that WebSocket of SignalR, and then at this point in time, you want this to connect as well. So there you go. Once both of them are connected to the same hub, now you can have a like these two um, clients are now just talking to each other, right? Like they keep sending a message to the group, and the group um, can kind of like respond accordingly. So for example, if someone attacks with a beak, and then someone attacks with a claw, right? So basically beak and with claw, so the beak wins, right? And there's like a deduction of HP. So you can also use evade, and you can use claw, and there's like a chance of how much you can evade or not, right? And then, for example, let's say if someone tries to exit the match or just disconnects, so you can kind of like also handle that and say, hey, you actually won the match. Your opponent disconnected, or you can also implement reconnections or things like that. But yeah, basically the fundamentals of something like PubSub or WebSockets, or in this case SignalR, is the concept of you need to have two clients talking to each other like instantaneously, right? You don't need to go through a huge data pipeline just for them to send messages to each other. So yeah, and that's where SignalR really shines. And with that, we're gonna close on with like a TLDR summary of the 6 services that we've discussed. So storage queue is again probably the simplest, and when you only need simple queues, like let's say someone what you just want to make sure that all the requests coming in gets inserted to the database at some point. Simple queues, you can use storage queue, and also the cheapest option of them all. Next, service bus is you have more advanced queues and consumer scenarios. You want more robustness. You want more configuration, more flexibility. Again, dead lettering. How do you want to handle retries? Like for example, if a message wasn't sent last, like yesterday, you just want to purge them because they're not relevant anymore. So those kind of like more advanced scenarios, service bus is the way to go. Next, event hub is when you kind of like want a large amount or high volume of streaming or batch of messages coming in, and you want to make sure you process all of them. Otherwise, if you do it by a service bus, you have to kind of like manage them individually, or at least on a specific topic. Event grid is if you want to have a multi-source and multi-consumer. And quite honestly, if you have the opportunity to build from the ground up with full Azure native capabilities, probably event grid is the best way to go. So that, again, less coding, less infrastructure to maintain is better. so that you have a reliable webhooks, reliable event triggers that's just always up. Next one is notification hub. Is when you need to push notification, a far and forget capability to various mobile apps and client devices. And lastly, SignalR or WebPub Sub is when you need real-time, communication across multiple clients. And with that, over to you, Brian, with what's next.
Yep. So just a couple more things. Some of the other Azure messaging services that we have yet to discuss. Of course, we're not going to discuss it anymore. Takes a lot of time. It's IoT Hub, which is like an event hub, but mainly for IoT. It has IoT features or features that helps you out with IoT between communication between IoT and other attached devices. You also have Stream Analytics, which would be working closely with IoT Hub, event hubs that perform real-time analytics. So there can be multiple streams of data coming in, maybe multiple event hubs, or coming from an IoT hub and event hub, but eventually is something that you can use to do real-time analytics. And for the ETL or ELT services from Azure, so what's the E for? I forgot the E.
Extract, transform, load.
Extract, transform, load, and then extract, load, and transform. You have the data factory, which is something that as a serverless data integration or that allows you to do data integration and data transformation is ETL. And you have Synapse Analytics that almost allows you to do everything. So that is also an analytics service that is, I would say, it's really humongous. You take a look at Synapse Analytics. It does a lot of things. A little bit of this and a little bit of that. So that is Synapse Analytics. And you have Power BI, which is used for visualization of your analytics and stuff. And other bespoke implementations, Michael?
All right. Yes. So what if you don't want to use Azure, right? Or maybe you want to use Azure but host everything on your own. What are your options? So one of the OGs as well in the .NET world is RabbitMQ. So it's an open source message broker that basically implements AMQP. So by the way, just a quick fact about RabbitMQ. They literally just released the streaming capability as well. I think just today. So it's now very head to toe with Kafka. So that's why it's kind of like the best bet within the .NET ecosystem. Second is Kafka. Like again, the most popular, I would say, probably the thing that revolutionizes the whole event-driven architecture, movement. So yeah, so there are, from just simple stream processing, there are now so many things you can do with Kafka. Yeah, and hosting that on Azure, you can either use Event Hub if it's a managed infrastructure. There's a Kafka for HD Insight if you want a more a little bit kind of like management on the Kafka side. And then obviously there's also an option of hosting it on Kubernetes or on your virtual machines. And some of the proprietary services out there, like nService Bus, and not just nService Bus. There are now a lot of emerging pay-as-you-go model servicing, message servicing in Azure and also other cloud providers that you can use. So that's kind of like a very popular discussion in the past few years about do you want to build or buy kind of scenario. So because again, once you reach certain amount of messaging thresholds, you have to consider like the maintainability of it, right? Like obviously you can't maintain 12 service buses with hundreds of queues happening around. Maybe you can if you have dedicated team around it, but at some point you have to consider when to build or when to buy. All right.
Yep. So yeah, that is all, guys. If you have any questions, you can ask us now, or if you have any questions that might that you might think of maybe in a couple of hours or maybe whenever, you can just reach us out. So you can go to our socials using this MJT Peña for Michael John Peña, and for me, Mind of AI. So you can also send out emails if you need to. If you want to discuss anything with us, you know, anything at all. So yeah, if you just want to get some references of the things that we just demoed, these are the links. So yeah, for the source queue and up to the notification hub. Yep. So those are the things, or those are the references which you can follow to kind of like get started with all of these services. So yeah, I think that is it. Again, if you want to reach us out, these are our socials and email addresses. And yeah, thank you so much for listening. I hope you learned something about Azure messaging services, or at least messaging in general.
All right. Thank you very much. Thank you very much. All right. I just want to give this to get this opportunity for to ask people if they still have questions, especially on the stream. Yeah, if anybody still has questions or any I am looking at the live chat on YouTube and Facebook. So again, if you have any questions, feel free to put them in. From our audience here, anybody else have any or was that? I mean, we haven't had an event in Microsoft for 2.5 years. So I guess a 2-hour stream makes up for it a bit. Yeah. So anyway, you knew where to reach them. All right. I'm going to take this opportunity to thank everyone who's been watching this stream. Thank you very much for joining us and being here for since 6:30 our time. It's now 8:30 here in Manila. From us, from Penny, thank you very much. From Brian, and from the rest of us here at Microsoft Philippines, we'd like to thank again Microsoft. Thank you, Ian, for this, and we'll just end the stream before we.
Can I just announce something?
Oh, sure. Go ahead. Please proceed over here.
Yep. All right. So hi everyone. So I'm Ian Dolores, but I'm known at Microsoft right now as Ian. So I'm the business program manager for Azure, covering Southeast Asia. So I just thank you for coming here in person and all of our hybrid participants joining us live. And I'd just like to announce that this coming September 30, we'll be launching Build Pilipinas. So this is an event for developers and IT professionals live here at Microsoft Philippines on Ayala. So it's for free. It doesn't have any registration. You just have to register. So watch out for our announcement through our Microsoft social media pages, and you'll be able to get to register. So there's a lot of. I think Brian will be joining us. We invited Brian to be part of the panel for Build. So and other MVPs coming in. So yeah, for our in-person attendees, right now we have a token for you, and I think for those hybrid attendees who answer or ask questions, we'll definitely send you some token of appreciation. All right. Once again, thank you for joining us here at the first hybrid community meetup of Philippine.net users. Thank you.
Brian. Thank you very much for joining us. Magandang gabi sa inyo lahat, and good night. Thank you.
So you want to do Azure notification hub sometime? You want to do Azure notification? We have a mobile app. Yeah. These customers ask for notifications.
Brian, can you give me one mask when you go here? The Microsoft mask.